In this video, we'll talk about complex numbers. So we've seen before equations where we end up with a negative under the square root. So in the real numbers, we've said that this is impossible, but now we'll get into the complex numbers where we can actually take the square root of negative numbers and it gives us something with which we can do interesting things. For example, completely factor a polynomial. So we'll do a quick motivation, we'll go into the definition, some arithmetic with complex numbers, and we'll talk about square roots of complex numbers. If we have the expression x squared plus 4 equals 0, and we want to solve this for x. Well, this one we don't really know what to do with. We know that x squared minus 4 is x minus 2, x plus 2, right? We know that that's just a difference of squares. But when we have this x squared plus 4, we end up with an x squared equals negative 4, and then x equals the plus or minus square root of negative 4. But we don't know how to do that. So now we introduce a special number called I, which is defined as the square root of negative 1. So then it follows that I squared is negative 1, I cubed is I times I, which then if I squared is negative 1, that gives us negative I. And then I to the fourth gives us I squared times I squared, which is 1. Just so you can know what to do with I. But this is the really important definition. I is defined as the square root of negative 1. And this leads us to define the complex number system. So the definition of complex numbers. A complex number is an expression of the form z equals a plus bi, where a and b are real numbers, and I squared equals negative 1. In other words, I equals the square root of negative 1. The real part is a, and the imaginary or complex part is b. We might say that two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. It's important to note that the complex numbers is a superset of the real numbers. In other words, the real numbers are a subset of the complex numbers with b equals 0. So now if we talk about complex numbers, that includes the real numbers. Just the real numbers are the specific case where the second part, the b there, is 0. So we might have some numbers that look like 7. We could have negative 6i, we could have the square root of 2 plus I, we could have negative 2 plus 36i. These are all complex numbers. In this first one, we have a real part of 7 and an imaginary part of 0. In this one, we have a real part 0 and an imaginary part negative 6. Here we have a real part root 2 with an imaginary part 1. Here we have real part negative 2 with imaginary part 36. Sometimes in cases where we have just the imaginary part, that is, numbers with real part 0, those are sometimes called pure imaginary numbers. Now, if I was given two imaginary numbers, let's say maybe I have z1 equals a1 plus b1i, and z2 equals a2 plus b2i. What do we need to do to add them? And my question is, what's the intuitive way to add them? Like you might think, okay, well, if we add the real parts and then add the imaginary parts, wouldn't that be the addition of complex numbers? Yeah, that's right. So if we do z1 plus z2, we add the real parts, a1 and a2, and then we have the imaginary parts, b1 and b2, so we have b1 plus b2i. Now we can't forget the I at the end because that tells us that those are the imaginary parts. Subtraction works similarly. We know that because in essence subtraction is just the undoing of some addition, or that's a way to think about it. So we might say that z1 minus z2 equals a1 minus a2, so we subtract the real parts, and then b1 minus b2. So we subtract the imaginary parts. Multiplication is kind of fun. So if we do z1 times z2, let's say that's a1 plus bi times a2 plus b2i. And this just looks like kind of the multiplication of two linear factors in a sense, right? Like we could call these two polynomials of degree 1 that we're multiplying together, which we then know we need to FOIL. So we multiply a1, a2 plus a1, b2i plus a2, b1i plus b1, b2i squared. Now remember what's I squared? I squared is just -1. So now we can rearrange. So we have a1, a2 minus b1, b2, since I squared is -1, plus a1, b2i plus a2, b1i. And then just to group it so it's clear, we have a1, a2 minus b1, b2 plus a1, b2 plus a2, b1i. And this is all summarized as adding, subtracting, multiplying, and dividing complex numbers. So for addition, if we have two complex numbers, a plus bi and c plus di, to add them, we add the real parts and we add the imaginary parts. To subtract complex numbers, we do the same thing. We subtract the real parts and we subtract the imaginary parts. To multiply the complex numbers, just like we would with binomials, we'll just FOIL them out. Now, division is a funny one. I want to introduce this first and then show you how it works. So if we're dividing a complex number, a plus bi, by c plus di, what we do is call multiply by the complex conjugate. So you can kind of think of this as rationalizing, right? If we have 1 over root 2, we rationalize that by multiplying by root 2 over root 2 to get root 2 over 2. Or if we have 1 over 2 plus root 2, to get rid of the square root in the denominator, we need to multiply by 2 minus root 2 over 2 minus root 2. So that's a really important thing to kind of keep in the back of your head. So now we multiply by the complex conjugate called z bar. If we have a complex number, z equals a plus bi, then the complex conjugate is z bar, and that equals a minus bi. So now let's see a quick example of that so you can process how that works. So if we have a complex number, 7 plus 3i over 4i. So essentially what we're saying is okay, well, let z equal 4i, which in other words, including the real part, is 0 plus 4i. Then this would imply that z bar equals 0 minus 4i, which just equals negative 4i. So now we take 7 plus 3i over 4i, and we multiply by negative 4i over negative 4i. So we're not changing anything, right? We're just multiplying by 1, which we're allowed to do since it does equal 1. So then we have negative 28i minus 12i squared. And that's all over negative 16i squared. What does I squared equal? That's negative 1. So we have negative 12 times negative 1 minus 28i over negative 16 times negative 1. So we have 12 minus 28i over 16. And we could simplify that if we wanted to. So that could equal 3/4 minus 7/4 I. And that's how you divide two complex numbers. So just to see it once more, a plus bi over c plus di, we multiply by 1 in the form of the complex conjugate. And lastly, in the case of the square roots, just like we have with real numbers, we have a positive and a negative square root. Since the negative 2 quantity squared equals 4, which also equals 2 quantity squared. So we have two square roots of negative r, and those are I, the square root of r, and negative I, the square root of r. So if we had a square root of negative 4, as we were talking about before, this just equals plus or minus 2i. Or similarly, if we had the square root of negative 9, I could write this out and we could say, well, okay, this is just the square root of 9 times negative 1, which is then the square root of 9 times the square root of negative 1. Maybe this makes it a little bit clearer. So we have plus or minus 3, and then the square root of negative 1 is I. Next video, we will look at completely factoring polynomials. We'll be able to use complex numbers to get the remaining zeros that sometimes we miss. So look forward to that, because that is the most satisfying part of looking at polynomials.